Okay, hello guys. So welcome back to the next topic of our chapter 2, pressure. Today we are going to look into same 2.1 pressure in liquid. But in this video, I'm going to explain to you on how to use the formula in pressure in liquid to solve the problem. Means that we're going to look into problem solving in pressure in liquid. Okay, let's move on. So like you all know, the formula for pressure in liquids is P is equal to H rho G. Now, this is what you learn, okay? So when we have this formula, it is very important for you to understand the concept of the pressure, okay? Because P is equal to H rho G is actually used to calculate the pressure at the depth in a liquid. Means that P is equal to H rho G refer only to the pressure in the liquid. Now, let's say if I give you a situation like this. Now, this is a glass of water. So where is the pressure? For sure, there will be something exerting on the top of the water, right? So what will that be? Now, the surface of the liquid also experiences pressure. They also experiences pressure. So by finding how to look into the actual pressure that being experienced, let's say we have fish inside the water. So what is the actual pressure that experienced by the fish? We have to take into the consideration of the pressure, atmospheric pressure. So that's why actual pressure is equal to H rho G plus P atmosphere. So P ATM is atmospheric pressure. Okay, remember the activity that I asked you to do in class? The activity that I asked you to do in class, where we have a plastic bottle and I asked you to poke the hole, right? There are 3 holes there, and then after that you close the cap of the bottle. And then what happened? I asked you to observe, right? So that situation, I have explained to you actually what is actually happening there that related to the atmospheric pressure. So here, same thing. You are going to use this concept. Please remember, to find the actual pressure is actually H rho G plus P ATM. Okay, H rho G plus P ATM. Now, let's go into the question. Now, this is the example. So, for example, figure shows a fish is at a depth of 1.5 meter in an aquarium. The density of the water in the aquarium is 1050 kilogram per meter cubic and the atmospheric pressure is 100 kilopascal. Okay, please remember the unit, it is in kilopascal. Okay, then the gravitational acceleration G is equal to 9.81 meter per second. What is the pressure experienced by the fish caused by the water around it? You see the question. The question actually asks what is the pressure that is being experienced by the fish caused by the water only. Next one, calculate the actual pressure acting on the fish. So you have to differentiate what is actually that you need to do here. Okay, now, so you know that P is equal to H rho G. So from the question itself, you know H is equal to 1.5 meter. My rho is 1050 kilogram per meter cubic. And then my gravitational acceleration is 9.81 meter per second. So to find my P is equal to H rho G. I just substitute whatever that I have, which is 1.5 meter times 1050 multiply with 9.81, then I'll get 15,400.8 Pascal. Okay, you can change the answer into kilopascal, no problem. If you want to leave your answer in Pascal, also no problem, as long as your unit is correct. Okay, now next one, I move on. Now, next question, calculate the actual pressure acting on the fish. Now, like I said just now, to find the actual pressure, you have to include the atmospheric pressure. So, my atmospheric pressure is 100 kilopascal. Do not forget that your unit is kilopascal. In my previous topic, in my previous question, I find 15.5 kilopascal. So I can directly use that 15.5 kilopascal plus 100 kilopascal, I get 115.5 kilopascal. If let's say you leave your answer in Pascal, then for this question, you have to change this kilo into Pascal and then Pascal plus Pascal. Okay, so please remember that. Okay, if you may leave your answer in Pascal, no problem, but make sure that your unit is correct. Okay, so that's what I need you to make sure about. All right, now let's move on. Okay, so for example 2, figure shows a U-tube filled with water and olive oil. The density of water is 1000 kilometer per cubic. Calculate the density of the olive oil. Now, I explained this one in class also because your friends asked me about how to look into the U-tube. So now I hope that you understand. So, like I said, if you look at this point, Okay, this point, see my cursor, right? So you look at this point, and this point, both of the points have the same, experience the same pressure. They experience the same pressure. Now in this question, I do not need to include actual pressure. I just need to take into the consideration of pressure in liquid olive. Okay, so I need to calculate the olive oil. Now I have my hedge here. Okay, and then I have hedge for the olive oil. So how to find? I know that the density of the olive oil, I write it as P2, rho 2, and then the density of the water, rho 1. Okay, I assume this one is rho 1, this one is rho 2. So my rho 1 is 1000 kilometer per cubic. And then the density of the oil, I do not know, so I write it as rho 2. Then I know the height of the water, H1 is equals to 15 centimeter. Here, 15 centimeter. And then the height of the olive oil, H2 is 16.5 centimeter. Now, because both are in centimeter, so no problem for me. Okay, because both are in centimeter, I can just directly use the value. Okay, so no problem. But if the question asks you to find pressure, make sure you are using SI unit. I repeat again. Let's say the question asks you to find pressure, make sure you are using SI unit. But because this question are asking you to find the density of the olive oil, so no worries. When you have left side centimeter, right side centimeter, you can cancel both sides. Okay, then I'll just substitute in my formula. You know that, right? Like the concept I said, the point here and the point here, both of them experience the same pressure. That's why P1 is actually equals to P2. So H1 rho 1G is equals to H2 rho 2G. So I just substitute the value inside. Before I substitute, I just cancel out my gravitational acceleration. Why? Because the gravitational acceleration are the same. So that's why I have H1 rho 1 is equal to H2 rho 2. Then I put in the value. I have 15. I use centimeter, 15 centimeter multiply with 1000. This is my density of water. And 16.5 centimeter multiply with my rho 2. So I bring this 16.5, I bring it to the other side. That's why I have 1000 times 15 divided by 16.5. Then I just press into the calculator. I get 909.1 kilogram per meter cubic. Okay, so that's what I have. Okay, so I hope that you understand here. Then that's all for this topic. Okay, now, so in the class tomorrow, I'm going to ask you to try on problem solving on the worksheets. Okay, so I hope that you understand here. If let's say you don't understand, just rewatch it. Okay, so that's all for this video. Thank you, class, and see you next video. Bye.